All right, welcome everyone. This is week 3 of OCHEM 1 weekly review. So last week we went over hybridization, function groups, sigma and pi bonds, resonance. We talked about how to find the major contributor and the minor contributor. And we also went over acid-base chemistry, and we went over an example using ARIO, which is like a acronym checklist that stands for atom, resonance, inductive effect, and orbital. So if you missed all of that, or if you need a refresher, look at last week's YouTube video. And then so today, because it's quiz week, we are covering all the topics that we can get to that is covered on your quiz. I believe some professors have different topics, so I'm more or less going to go with the majority. I think besides what we covered last week, nomenclature, which is naming your alkenes, isomers, and IR will be on your quiz. If Chair, Newman, and Fisher is on your quiz, I would recommend going back to previous years on our YouTube channel and looking at those weekly reviews. If not, we have other resources. Of course, you can look through e-learning material or YouTube videos. All right, so before I start, any questions? Any questions from you? Okay. All right, so let's get into it. I'm going to start off with nomenclature. One second. Okay, if you guys ever have questions, just let me know in the chat. I'll get to it. Okay. So nomenclature is kind of a big topic. And by big topic, I mean there's a lot of rules and different aspects to it. So let me draw out. So the first thing you have to identify is the parent chain. Okay, so let's say, for example, I have something that looks like this. Okay. So obviously, I only have carbons and hydrogens, but so to define a parent chain, it's basically your longest carbon to carbon chain. Okay. So you're counting carbons to see how long you can go up to. And let's go through this example, okay? So let's say I count from left to right. So I'm going to count 1, 2, 3. So notice that 3, I can go 2 different ways. I'm going to go to the right. Okay, so I can either go left to right, or I could go left to bottom. So 1, 2, 3, 4, 5, 6. So notice how going bottom, you get 1 extra carbon, and that's going to be your longest chain. Okay. Something to keep in mind is once you found your longest chain, you can also technically count backwards. Okay. And there are rules depending on which direction you count. Okay. So so notice the difference is between 3 and 4. So if let's ignore the red ones for now. Oh. Okay, so if we ignore the red markings, I'll rewrite that. Okay, we have the green and the blue. And And then the only difference is this right here, because so once you found out your chain, you're gonna circle your substituent. Which is, so this is called a substituent, and this is basically anything not included in your parent chain. Okay, so we'll get to the substituent later, but we want to realize the numbers our substituent is numbered. So if I went left to bottom, I get 3 on my group. If I went bottom to left, I get 4. Okay, so we always want the lower number. So number 2, which we kind of already did, is identify your substituents. Okay, which we already did, but I'll give another example. Okay, actually, so same example, and we already said this. So we already said this is our substituent, right? And based on the green and the blue, we agreed that green would be best pathway. So this is 1, 2, 3, 4, 5, 6. So on 3, we have this substituent, okay? So we have to figure out what substituent that is. Do you know?
That's the ethyl.
Yeah, it's an ethyl group. So this is a ethyl. It's an ethyl because it has 2 carbons. So quick little lesson. You have methyl, ethyl, propyl, and butyl. So methyl is CH3. Ethyl is going to be CH3, CH2. Propyl is going to be CH3, CH2, CH2, and then butyl, you're going to add upon that, so you just keep adding on CH2s. Okay? So now that we identified ethyl and we realized 3 is the lower number, so going back to this point, we want our substituent on the lowest numbers. So put these on the lowest numbers. Okay. So to name this, we always start off with our parent chain. So 6, so that means it's hexane. Hex is because it's 6, ane because it's single bonds. Okay? If there's a double bond in here somewhere, it'll be hexene. Okay? So besides our parent chain, we have one substituent that we also have to name. Okay? So the first step is to look at the number the substituent is on, which is 3. So we put the number, we put the dash, and we put what the substituent is called, and it's called ethyl. Okay, and you don't necessarily need to put a dash between the last substituent and the parent chain, but if you want, I don't think it's necessarily wrong. Yeah, I'm actually going to not put it. But yeah, so that would be this structure's name, 3-ethylhexane. Okay, we'll go over another example. So let's say you have okay, so let's say you have that example. So obviously slightly tricky or harder than the other example. So we're actually going to delete that. Okay. So you want to be very careful with numbering again because numbering determines your entire structure. So if I go from left to right, I already know it's not going to be accurate because I want more substituents on. So wherever you see more clutter, that could give you a hint where most of the substituents should start. And looking at from like the normal way, the horizontal way, versus here, because these are also substituents, I can tell that this has more. So I'm going to start off with the bottom one. 2, 3, 4, 5, 6, 7. And then I'm also going to circle my substituents. So I have that one, I have this one, and this one. Okay, so I have 4 substituents. Okay, so let's identify these substituents. This is ethyl, and all 3 of these are methyls. Okay, so if you're having trouble figuring out how do I know if it's methyl, ethyl, propyl, or butyl, just count the number of carbons. So remember, each vertex is a carbon. So 1 carbon is going to be CH3, which is methyl. 2 carbons is going to be ethyl. Okay? So now that we got our parent chain, identified our substituents, let's kind of start putting this together. So 7 is hep, and then it's all single bonds, so it's going to be heptane. Okay, so this is our parent chain. Again, this is because it's 7. This part is because it's single bonds. Okay, so we have to name all 4 substituents, and if we have the same substituents on different carbons, or even on the same carbon, we are going to group those together. So I have 3 methyls, right? So I'm going to put a number on all 3 methyls. So these 2 methyls are carbon 2, and this is carbon 5. Okay? So to group them, it's going to be 2, 2, 5 dash, and then because I have 3 methyls, I'm going to put tri dash, or no, there's no need for dash. You just put methyl. Okay? All right. So this is our methyls. We also, remember, have our ethyl, which luckily we already did the exact same thing up here. So I'm gonna just write that out. It's ethyl and it's on carbon 3, so it's 3-ethyl. Okay, now we have to figure out which substituent goes first. Okay, and for now, or for the most part, it's always going to be alphabetical order. Okay, so we have to look at the M and the E. Okay, so obviously E comes before M, so that's why our total name, or the full name of this compound, is going to be 3-ethyl 2, 2, 5 trimethyl, and then heptane. Okay. So slightly harder question, but hopefully that should make sense. If you guys have any questions, let me know. Okay. So let me see. So some other types of substituents that you might encounter. Well, actually, first let's go through all the basic ones. So here, I'm just going to draw a very long chain. So I have my methyl, I have my ethyl, this is my propyl, and in propyl, I could have a regular propyl, and I could have a isopropyl, and I'll label all of these later on. And then, so propyl, isopropyl, that's all I can do. Next is butyl, which is 4 carbons. And then in butyl, I also have a isobutyl. Let's not draw that way. Okay. I have a sec-butyl, and then I have a T-butyl. Okay. Now I'm going to label all of these. So methyl, ethyl. So this is called N-propyl. This is called isopropyl. Okay. Once I finish labeling it, I'll explain where everything is coming from. This is called N-butyl, and this is called isobutyl. So isobutyl you very rarely see. This is called sec-butyl, and this is called T-butyl or tert-butyl. Okay. So methyl ethyl should be very self-explanatory, and just in case, I'm gonna put a circle or a dot for all the carbons. So methyl, as you can see, only has 1. Ethyl has 2. Both of the propyls have 3, and then all 4 of the butyls have 4. Okay. Okay. So also notice how if this was a problem, this would obviously be my longest chain. Okay. Because visually I can see the carbon length extended far, just down the middle. Okay, so my parent chain is all the carbons in blue. Okay, so any other carbon that I haven't, that's not included in the parent chain, is going to be considered a substituent. Okay, And these are the common carbon substituents. Okay, you have your methyl, ethyl, propyl, and butyl. Okay, so methyl, ethyl are self-explanatory. There's nothing special about going on. Propyl has a special variation of how it looks like, which is this word right here, iso. Okay, so iso stands for isolated at the very end. Okay, so at the very end, at the very end, branches off final two carbons. Okay, so just like you see in isopropyl, you see the same branching off in isobutyl. Okay, it branches off in two directions. Okay, so for sec-butyl, so sec means secondary. Okay, so secondary means that at the beginning, it branches off. Okay, so we have one direction going here and one direction going here, the rest of the molecule going that way. So very similar to iso, but it's at the beginning. Now T-butyl or tert-butyl, so T slash tert stands for tertiary. Okay, which stands for 3. So 3 branched carbon at 8 points. Okay. All right. So these are common carbon methyl groups or substituents that you should know. You need to know like the name of it because that's important for the nomenclature. So as far as alphabetical order, I believe sec and T-butyl do not count. So whenever you're looking at sec and T-butyl, you only look at the letter B. And then, but for iso, you do count. So I'll write that down. So iso counts, sec, and tert don't count. I'll just say alphabet right here. Okay. All right, so we'll move on to substituents not carbons, like halogens, alcohols, and double bonds. Double bonds we might actually not need to worry about. That's unit 2/3. Okay, so let's say I have an alcohol here, a bromine here, and a chlorine here. Okay, and might as well just do all the halogens. Okay, so to number my carbon chain, there is a particular order. Okay, so alcohol is going to take priority over halogens. Okay, so which is why our carbon number 1 is actually going to be right here, not over there. Okay, so this is 1, 2, 3, 4, 5, 6. Okay, so I'm going to circle all my substituents. Chlorine, bromine, fluorine, iodine. So alcohol is technically also a substituent, but it's a special substituent, and we'll talk about what that is. Okay, so my parent chain is going to be 6, which is hex, and then because it's single bonds, it's going to be AN, but because I have a alcohol, it's going to be OL. Okay, so anytime you have an alcohol, you're always going to have the OL ending. Okay, so again, this is because it's 6. This is because it's single. And this is because there's an alcohol in the parent chain. Okay, and you, so I'll write down the priority. So it's OH, and then SH, and then, so I think it's, so basically it's all the other, like double bond. So yeah, we'll just worry about single bonds for now. Okay. Well, halogens take priority after. Okay, and then it's single bonds. Okay. So, and we don't need to put 1-OL. That's like, there's like a new IUPAC and an old IUPAC. You can do either or. So looking at our substituents, we have 2 dash. So all of these, so iodine is going to be iodo. Fluorine is going to be fluoro. So 4 dash. Chlorine is going to be chloro. And then 5 dash bromo. Okay. And for halogens, it is also alphabetical. So we have to put, so our total, our full name is going to be 5 dash bromo dash 3 dash chloro. And then after chlorine, it's going to be F, so dash 4 dash fluoro dash 2 dash iodo, and then iodohexanol. Okay, so that is your full name of this compound, which contains halogens and alcohol, and we discussed the carbon. So we are missing our methanol group. So it's 1. Well, actually, never mind. I don't think I wrote this correctly. So that should not be. Oh. Okay. So this should actually be 1. I thought 1 would go with hexanol with alcohol, but I think that's not always true, because you two take priority over the parent chain. I'm not entirely sure on that. Yeah, so just shift everything over. Our substituents are still the same. This would just be heptanol. And then for 2, I think the way we write this is heptane-2-OL. I believe that's how you write it. And then all of this should just be shifted over. So this would be 3. This would be 5. This would be 4. And this would be 6. Okay, so apologize for that. But I would double check, the professor's way, because maybe different professors have different priority, and something on the internet might be conflicting what you learn here or in lecture or on a random YouTube video. So yeah. So there's that. And then I'm gonna scroll back up to this if anyone needs to take a picture or anything. I don't see any questions. Okay. And then there's the other part. Methyl ethyl propyl butyl, the parent chain. And yeah. Okay. So any questions on nomenclature? Do you have any questions? Okay.
You answered most of what I had.
Huh?
You answered most of the questions I had.
Okay, cool. Anyone in the chat or watching live have questions? Okay. So we went over nomenclature. Now I'm going to quickly go over isomers. We'll see if we have time over IR. IR, I believe you are getting the charts for it, so hopefully it won't be too bad. Okay. So isomers. Okay, so some of these I'm not quite sure if you guys have learned it yet, but I'm gonna still teach it, and whenever you get to it, you'll know it by then. Okay. So there is something called chirality. Have you heard of that word?
Nine.
Okay. Have you heard of enantiomer or diastereomer? Okay. So what isomers have you guys covered so far?
Force transits is.
Okay. And for those of you in the chat, do you guys know what isomers have you guys covered yet? Okay, I mean, I will go over that, but I might go over extras. So if the extra doesn't apply to you yet, or if your professor hasn't taught it, don't worry about it. But whenever you do learn it, you can come back to this YouTube video. So there's something called RNS we'll talk about. So this is an enantiomer. Okay, and this is diastereomer. Okay. So besides those two, there is also cis and trans, of course. And there's identical, which just sounds exactly what you think it is. There's not related, which also sounds exactly what it says. And then there's resonance, which is the easiest of all. And then one last one, which is something you should know. It's called constitutional / structural. Okay. All right. So let's see. Geometric and constitutional. Okay. Yeah, geometric is similar to structural, I believe. I'm not really sure like what the words are interchangeable, but so let's start off with resonance. It should be the most simple one. So I'm just gonna do a very basic one, but to just understand, it could be any resonance problem. So if they give you two compounds, obviously they're not going to give you the arrows. So I'm not going to do the arrows either. But if they give you compound A, or compound 1 and 2, just know that those are isomers of each other. Okay? Not related means that the formula is completely different. So let's say they give you three carbons, one bromine, 7 hydrogens, and then structure 2 has the bromine, but it also has chlorine right here. Okay, so if the molecular formula does not match, that means it's not related. Okay, so constitutional isomer should also be fairly straightforward. So let's say my molecular formula is C5H12. There are different ways I can construct this. So I could do it the regular way, where I just draw my carbons back to back in a chain, or I could move one of my carbons and make it into a substituent like that. Okay, and you can always double check by counting all your carbons and hydrogens if that matches up. Okay. So yeah, if structure 1 and structure 2 looks like that, then it's going to be a constitutional / structural isomer. Now, cis and trans is going to be the other easy one to explain. So let's say we have a double bond like that. And so on both sides of the double bond, you're going to have A is going to be your like heavier, bulkier compound, and B is going to be your smaller compound. So not smaller or bulkier. Let's say they're the same compound. Okay, so instead of examples, I'll just do an actual example. Okay. So let's say I have a double bond. Let's say I have methyls there, and I have chlorine, chlorine. Okay, and then in my second example, I have chlorine here, chlorine there, and my methyls on opposite sides. This is obviously going to be cis, this is going to be trans. Okay, that's compound 1, this is compound 2. Okay, so cis and trans, so cis means they're on the same side. Okay, trans means they're on opposite sides. Okay, so cis can also look like using wedges and dashes. Okay, so if you have two wedges, that means they're both pointing the same direction, sterically. And then likewise, you can also have dashes. Okay, and then trans would be one wedge, one dash. Okay, so you can either see it through double bonds or you can see it through wedges and dashes. Okay. All right. Any questions so far? Okay. All right. So to explain enantiomer, diastereomer, and identical, I'll have to pivot a little bit regarding what chirality means. And identical should more or less be same. It means you have the same molecular formula and they're constructed the same way. But it can be slightly different. Okay, so chirality is, let's say you have carbon, and let's say you have, so in order for something to be chiral, and so chiral equals 4 unique substituents. And I'll abbreviate substituents from now on to sub. Okay, so this carbon, let's say it has a chlorine, bromine, a methyl, and a hydrogen. Okay, so we would say this is a chiral carbon. Chiral carbon. Okay. Now, something we have to understand about chirality is R and S. So R is clockwise and S is counterclockwise. Okay. So the clockwise and counterclockwise, we are basically numbering our 4 substituents in terms of weights and how bulky they are. So obviously hydrogen is going to be our number 4, and then it's going to be methyl as at number 3. Now looking at bromine and chlorine, which one is heavier? It's going to be chlorine. So chlorine is going to be our biggest one, and then it's going to be, chlorine, it's the opposite. Bromine is going to be heavier than chlorine. Okay? Yeah. So so after looking at this, we always put the arrow from 1 to 2. So we go this way. So even though 4 is coming before 3, it's fine that the arrow is going to be counterclockwise because it's always 1 to 2. Okay, so we would say this example is S. Okay. So in that manner, let's say you have structure 1 and structure 2, and let's say they have 3 chiral carbons. If structure 1 has all 3 chiral carbons in the R configuration, in order for this to be an enantiomer, structure 2 has to completely flip the direction of the chirality. Okay, so an enantiomer is essentially a mirror image. So all chirality must flip. Okay? So diastereomer is something very similar. So again, let's say you have compound 1 and compound 2. Let's say our first one is again R, R, R. The second structure, only one is required to flip. Okay, so at least one chirality must flip. Okay, so that's the difference between enantiomer and diastereomer. Enantiomer, think of it like a mirror image. Okay. So if I have 3 R's, it's going to be 3 S's. And the diastereomer, if it's 3 R's, it could be SRR, SSR. But if it's SSS, then it's going to turn into an enantiomer. Okay. So those are your RNS, like isomers. And again, the concept of chirality may be talked about in lecture later on. Okay, so in order for something to be identical, it has to be the same molecular formula and it has to have same chirality. Because you could have the same molecular formula, but if the chirality is different, then it's an enantiomer or diastereomer. Diastereomers and enantiomers have the same molecular formula. I'll write that. Same molecular formula. Okay, so let's say if my one is RSR, then my number 2 has to also be RSR. It can't be SRS or any other variation. Okay? So that's isomers altogether. And I know some of that was new, may not even be on the quiz tomorrow. It may show up in lecture before the exam, hopefully. If not, at least know the green ones, because those will definitely be related. Okay? Any questions on any of this? Okay. There is a little bit more to chirality. It's not always on lines. Sometimes you'll have to flip things based on where the 4th carbon is. And I can quickly write that down. So you always want your 4th carbon. So this is for the 4th one. So you always, if it's on a dash, you're going to keep the chirality. If it's on a wedge, you flip. So whatever chirality you get, let's say you get R and your 4th lowest group is on a wedge, then you flip it. And if it's on a line, then you have to rotate the bond so that it's on a wedge or a dash. Okay? Again, I don't know how much in depth they'll go into, or if this has been talked about. Someone said, don't all isomers have same molecular formula? Yes, so that is true. Yeah, my bad. So all of them should have the same molecular formula, except obviously the not related one. But I just wanted to make sure that it's understood. An enantiomer and disomer also have the same molecular formula. Okay, but yeah, good question. All right. So, let's see. Okay, any questions? Do you have any questions so far? Okay. So I think I'm gonna stop it here. Actually, we'll discuss IR. Maybe not for the quiz, but for the exam, we'll definitely review it. But for now, I would recommend maybe going back to one of the older weekly review peer tutoring videos or another video on YouTube, or just look at the lecture notes. They do give you the values, so that should hopefully be somewhat easy. But definitely review functional groups, which I discussed last week, because that will definitely be important. So all of these functional groups, so just like a quick lesson about IR, all of these functional groups and any bond has energy, and IR is basically how much rotational energy or how much energy it takes to break that bond, okay? So carboxylic acid has a very unique energy and has a specific value. So carboxylic acid and alcohol are very broad peaks. And all of these carbonyl ones have a peak around 1700, okay? So they have a peak around 1700, and then carboxylic acid has another additional peak around like 3300 because due to the alcohol, okay? Aldehyde has a specific pattern with the twin fangs around 2800. Benzene is 1660 or 1600, something like that. Alkene, remember carbon, triple bonded carbon, as well as carbon, triple bonded nitrogen. They're around 2200. So these are specific patterns you should watch out for. And if you see peaks around like right below 3000, it doesn't really mean anything. It's just carbon CH bonds, which you get from like just a simple carbon chain. So yeah, any questions on all that? IR is essentially you're given a puzzle like graph and you're trying to match it to like hopefully they'll give you like a compound like answer bank that you can just match to. You don't have to like actually draw out the structure. Okay.
And they won't make you go from structure to an IR.
No, you don't ever have to draw the graph.
Sorry.
Yeah, no, that will never happen. So IR is an OChem 2 concept, actually. This is the first year they're bringing it to OChem 1. So you might have a review on IR in OChem 2. So yeah, and this is kind of talked about in OChem lab, actually, like towards the end of OChem 1 lab. But yeah, so hopefully the IR questions won't be too difficult, but I do recommend at least watching a video on it. I believe they'll explain everything that you need to know. Okay? All right, we're gonna end it here. Let me know if you guys have questions. I'm gonna stop the recording, but you guys can continue asking questions. All right, see you guys next